I've watched many amazing videos of other great channels that very scientifically test the strength of different printed materials, but I'm still left questioning about a practical use case. Like roughly how much weight can a 3D printed shelf hold? So I decided to do some tests of my own with a few different designs. 2 brackets support the shelf from below, 1 suspends the shelf from above, and the last is a floating bracket design. The brackets are 5mm thick with 8 perimeters, making them mostly solid except for the corners. Due to the shape of the floating shelf bracket, this has a larger infill area. All brackets were printed with Polymaker's Polylite PLA Pro. In order to test the brackets, I needed some kind of test rig, so I came up with this setup. It's made out of 5 2x4s and some other odds and ends. 4 of the 2x4s are cut in half and attached together to create 2 roughly 4-foot boxes. Then those 2 boxes are attached 16 inches on center apart, which is the common wall stud spacing in North American homes. The shelf is an 8-inch by 22-inch board with an eye bolt in the center. This is so the shelf will be pulled straight down, similar to if something heavy was sitting on it. To apply the force, I'll be using 2 3-pulley tackle blocks. This setup multiplies the pulling force on the rope by 5 times. To pull on the rope, I'm using a piece of ABS plumbing pipe with 2 screwdrivers to act as levers to create a simple winch. This way the forces are all contained inside the test rig and I don't have to worry about pulling it across the floor. To measure how much force is being applied, I'm using a digital crane scale. It's rated for a max load of 150 kilograms or 330 pounds. So after a little building montage, we'll get to testing. And here's the final setup. The yellow ropes are added for something to catch the shelf when it falls. Bracket 1 is a standard L bracket design with an angular brace. Let's see what it can hold. I just wanted to pause for a second here to point out that the weight is at 150 pounds and the shelf is showing almost no deflection. I was not expecting this.
I am shocked. Shocked! Well, not that shocked.
If you're finding this interesting, let me know by hitting the like button. It really helps to get YouTube to show this to more people, which helps the channel grow. Also, consider subscribing if you don't want to miss more videos like this, and let me know in the comments what you think so far, or what I could have done differently. Alright, let's keep going. The scale maxed out, so I don't know the exact weight it failed at, but it's greater than 395 pounds, which is crazy. On to bracket number 2. This design has the shelf hanging below the bracket. I also changed where the scale is located in the system since it was maxed out last time. Now the scale is on the input rope, so any measurement is multiplied by 5. At 600 pounds of force, the board started to split, so I had to stop. I didn't want to rip the eye bolt right through the board. So I'll make some upgrades to the shelf and we'll try again. Bracket 2, take 2. So another technical issue with the scale. After reaching 700 pounds, you can hear a beep, and then the display stays locked at 55 pounds. This is a feature of the scale that when the weight stabilizes for a moment, it locks so you can get a reading. I thought once more force is applied, the scale starts updating again, but that's not the case. You have to manually unlock it, and I didn't notice it was locked. Bracket number 3 is another L bracket design, but this one has a full gusset between the two arms of the L. Almost another scale issue, but luckily I noticed this time and was able to unlock it. This shelf had surprisingly little deflection throughout the whole process before it failed. Bracket number 4 is the floating shelf design. This bracket works by having one half attached to the wall and the other half recessed into the shelf. Then the shelf just clips onto the wall piece and there's no visible supports. Before it can be tested though, some modifications need to be made to the shelf. Here's a close-up to see how the bracket works. So this was interesting. I wasn't expecting it to hold much weight, but I'm surprised that it held 150 pounds before bending. Also, there was no damage to the brackets. They just pulled out and bent the screw to the point where the teeth slipped apart. After all the tests were done, I wanted to try a bracket with more normal settings. So Bracket 5 is the same design as Bracket 1, but it's only printed with 3 perimeters. Well, this was much weaker, but it still held 175 pounds before failing, which is way more than I thought it would. Now let's take a look to see how the brackets failed. For bracket number 1, one side has almost no damage. You can notice a slight bend near the top screw hole, where the bracket was flexing. The other bracket exploded, and I don't think I found all the pieces. The parts attached to the wall split in half along the screw holes, and the brace snapped at both ends. It looks like the failure points where the solid walls met the infilled areas. If the brackets were printed completely solid, they may have held even more weight. For the second bracket, both failed the same way. Just before the bracket failed, you can see the top screw had broken the top part of the bracket, and then both brackets split along the layer line lining up with the screw holes. The third bracket was similar to bracket number 1, with one side having minimal damage. The top rail had half broken off along the screw holes due to the shelf twisting as the other bracket failed. The bracket that failed sheared off along the backing plate. It seems like a similar issue to bracket number 1, where it broke where the walls met the infilled section. Bracket 4 didn't have any damage itself. It was just able to apply enough leverage to the screw to pull it out of the wall and then bend it to the point that the two parts slipped apart. Bracket 5 failed in a way I was expecting it to, but it still held way more weight than I thought it would. There wasn't really any stress or damage to most of the bracket. The two top screws just broke through the outer wall and then proceeded to rip through the rest of the bracket with little resistance. Here's all the stats for the different brackets. Even though there were some issues in measuring some of the shelves, I think the takeaway is that 3D printed shelf brackets are a viable option and hold way more weight than I thought they would. If you find my experiments like this interesting, please hit that like button so it gets shared with more people. If the video gets enough views, I might do another test and try some other designs and maybe other materials. So let me know in the comments what kind of designs and materials you'd like me to try. Also, don't forget to subscribe if you want to see more videos like this, and thanks for watching.